1/25th scale models are large enough that replacing molded-in screen texture with actual etched metal mesh is both feasible and visible on the finished model. After all, no point going to the extra effort if it won't be seen. Scale modeling is all about creating an illusion, and sometimes reproducing parts to exact scale size makes them too delicate or too difficult to see, as in the case of the screen texture on the fresh air inlet on Ertl's Transtar 4300. It's hard to see even as raw plastic, and under a coat of primer and paint, it'll be even more difficult to see. This is a good candidate for removal and replacing with etched metal mesh. Begin by drilling a series of holes around the edge of the molded-in screen texture, keeping the holes as close as possible. I like to use an 032 diameter drill for this operation. Use a sharp hobby knife blade and carefully connect the dots to remove the cutout section. At this stage the opening still looks a little rough, but careful work with an assortment of fine files will result in a nice clean square opening ready for the installation of etched metal mesh. One of the realities in our scale modeling world is that injection molded kit parts, such as this cab shell, are often proportionally much thicker than the sheet metal components that they represent. This compromise is necessary to produce parts of adequate strength, but leads to the problem that simply gluing mesh on the back side of the shell, as done here, doesn't look right because the mesh is set so far back from the outer surface of the cab. One way that this can be addressed is by carefully cutting and fitting the mesh so it's a slight friction fit inside the opening, allowing it to be flush mounted. Filing a slight taper on the inside edges of the opening can help, and in fact I used this approach a number of years ago when fitting etched mesh to the intake opening on an Italeri Pete 378. Fitting the mesh this way does work, but it's quite tedious and time consuming, and there is an easier way. Start by measuring the actual thickness of the cab shell in the area where the mesh will be fitted. In this example, the cab shell is 0.53 or 53 thousandths of an inch in thickness. The mesh I am using, which is made by K&S Engineering, is 1/32 square fine, and it measures 8 thousandths of an inch in thickness. Subtracting the thickness of the mesh from the thickness of the cab shell works out to 45 thousandths of an inch. For scale modeling purposes, 40 thousandths of an inch is close enough, so I will use 10 thou by 40 thou styrene strip to line the edge of the opening and create a ledge for the mesh to sit against. A small piece of sheet metal is clamped in place to align the inside edge of the styrene strips. I used a piece of 016 aluminum, but brass or copper will work just as well. No high-tech tools needed here. A small clothespin and a piece of balsa work just fine. Each piece of styrene strip is measured and cut to length, and then secured with solvent cement. Solvent cement will tend to pull itself between the strip and the sheet metal piece, but this won't cause any issues because it won't bond to the sheet metal. With styrene strips glued in place, a ledge has been created around the edge of the opening, which is now ready to receive the etched metal mesh, which sits close to the surface and is securely held in place and looks much better than the molded-in screen texture. The same approach works well for windshields on models where the thickness of the cab shell would result in the windows having an unrealistic inset appearance if they were installed in the conventional kit manner. This was done on a White-Freightliner by lining the inside of the windshield opening with styrene strip and cutting 10 thou styrene panels for flush-mounted windshield glass. AMT's Kenworth cabover is another ideal candidate for this approach. On this model I used 20 thou by 20 thou square styrene strip glued around the inside of the windshield opening, with separate pieces installed at the outside corners to support the separate angled pane of glass, which was modeled with 10 thou clear styrene for both the windshield and the angled portion, with a separate black painted styrene strip added after installation to simulate the rubber gasket connecting the angled pane at the corner with the main body of the windshield. And mesh can be added to all sorts of other openings as well, such as the roof vent and sleeper vents on this Mack R, which were often open when I drove the real truck because it wasn't fitted with air conditioning. Cut the vent opening first, and then install the mesh, followed by installation of a styrene strip, cut and sanded to simulate the vent door, with small triangular styrene pieces top and bottom to represent the mechanism upon which the vent door hinges. The majority of the time I would have the sleeper vent set in this manner, facing to the rear, to draw air out of the cab, and the roof vent open forward, scooping fresh air in. Again, in this view, you can see the styrene strip used to make the vent itself, with the small triangular pieces representing the sides upon which it pivots. Interior view shows styrene strip trim piece around the vent opening, etch mesh in the vent, and a small piece of styrene rod representing the operating handle. And the single sun visor is accurate. There weren't a lot of frills on the real truck. And we've come full circle back to the opening photo, bringing us to an end at this look into the world of added details from model truck projects. With the air scoop glued in place, the etch mesh texture is still visible from the correct viewing angle and adds greatly to the appearance of the finished model. Adding etch mesh to vent openings and other areas on your models is feasible in 1/25th scale and worth giving a try.